Hey guys, my name's Ryan, I'm with CoursePics, and in less than 2 minutes I'll teach you everything you need to know about DNA replication, and it will take a test to prove that you know it. So here you have this crocodile who's a reptile, and he's representing replication, so that's going to help you with the DNA replication part. Here's his buddy, top ice hat, Pac-Man, who represents topoisomerase. He's unraveling the strand of DNA, followed by this helicopter Pac-Man who represents helicase, and he's separating the strands of DNA. And this guy right here, this protein bar, he's holding the strands open with this single-stranded rope, and he represents the single-stranding binding proteins. And here's the leading strand represented by the lead car, and you know this is the parent strand because there's a pair tree at the end of it, and you know it's the 3' end because there's the number 3. The tree sound a lot like 3. Since that's the parent strand, right above it is the new strand. And so these DNA nucleotides are represented by dino heads. Here, this new strand, this dino is giving this primase a high 5, so that represents 5' or the 5' end. And it goes from a 5 to a 3. And if you notice, you see this telephone mirror, and of course that represents the mirror. So that's the lead strand. Right below here is the lagging strand, shown here by the construction worker. You know, we all hate construction, it slows everything down. So first off, you have the primase who's working really hard because it's the lagging strand, it goes slower. He is laying down rhino heads that represent RNA, and that's followed up by a DNA polymerase, shown here by polywanacracker. Here in order, you have the DNA polymerase followed by the ligase. This is a ligase. And then here the zookeeper, he's saying okie dokie. Again, that's going to help us remember Okazaki fragments. As promised, I downloaded some DNA replication questions, and let's check them out. The actual synthesis of DNA in E. coli is a function of, and so we go back up here to our DNA synthesizer, or the DNA painter. Poly wants a cracker, so that'd be polymerase A. By convention, the sequence of bases in a nucleic acid is usually expressed in the what direction? So again, you go back to our newly synthesized strand here, and it starts out with a high 5 from our primate and goes in the 3' direction. So we'll say 5 to 3'. So that's always, whether it's lagging or leading strand, it's always 5 to 3'. Next question. Okazaki fragments are used to elongate. And again, here's our lagging strand here. Here's Okazaki. So it's associated with the lagging strand. And so we'll skip the leading strand. And this says the lagging strand toward the replication fork, and that's false. As you see, our DNA polymerase is painting on his last dino head, so it's going in a left to right direction. The lagging strand away from the replication fork, and that's the correct answer. Next question. In replication of DNA, the helix is open and untwisted by, and if you remember our little helicopter, he's the guy that is separating the two strands. And so we'll put B, ligase. Blank, join DNA fragments to the lagging strand. So go down to our lagging strand here, and the guy last in line is our liger. He's the one that joins the two strands after DNA polymerase does his job, so ligase. And that would be D. Next question. Which statements about the elongation of the lagging strand during DNA replication is correct? So again, it's asking about the lagging strand. It's synthesized in the 3 to 5' direction. That's false. It progresses towards the replication fork. We said that was false. It requires a short RNA primer to proceed, and that's correct, right? So the primase, or the primate, is painting these rhino heads, which represent RNA. Hey guys, that's it. I'll see you next time.